Do you know how long it took for Facebook to hit 100 million users? 4 years and 6 months. WhatsApp hit the same target in 3 years and 6 months. And TikTok did that in just 9 months. Since 2017, TikTok was famous for reaching 100 million users, the fastest in human history for 5 consecutive years. But this record was broken in 2022 by an unusual app. This app collected 100 million users in just 2 months. And unlike the previous ones, this was not a social media or a messaging application. It was an AI model, ChatGPT. The model was so revolutionary that it spread all around the globe rapidly. For the first time ever in human history, a computer was as smart as to execute the most sophisticated tasks with simple text-based prompts. Training such a complex AI model is a resource-intensive process that requires a significant amount of computation. In fact, in 2018, OpenAI, the company behind ChatGPT, announced that the amount of compute used in largest AI training runs has grown by 300,000 times since 2012. But what it takes to operate these superpowered machines? The answer is energy. Traditional Google search uses a tiny of 0.3 watt-hour of electricity. But if Google were to use AI for their search engine, every search will use nearly 10 times more electricity. Many people find the AI revolution very similar to the revolution of internet. It is certain that we'll see the exponential growth of AI usage in the upcoming years. And one may wonder, what about the energy use of AI? Will AI adoption cause another energy demand boom? How much energy do we expect AI to consume in the upcoming years? Let's first look at the current energy footprint of AI models. When it comes to the energy consumption of AI in general, there are 3 major components to consider: hardware, training, and inference. In this video, we will focus on the last 2. AI model training is like teaching a computer to recognize patterns by showing it lots of examples, similar to how I learned to identify monkeys as a kid by looking at many different pictures of them. The training process involves feeding the computer with millions of data points and adjusting its understanding until it can make accurate predictions or decisions on its own. Inference is the time when the end users like us start to interact with the AI model. This is when the trained AI model uses its previous learnings to make predictions or decisions based on new data entered by users. Think of this like a kid who has seen pictures of monkeys but not gorillas. When shown a picture of a gorilla, the kid will analyze it, find similarities with the monkey images he has seen so far, and eventually conclude that the animal in the picture he is seeing is a type of a monkey. Training and inference consume a lot of energy because they require intensive computational power to process large amounts of data and perform complex mathematical calculations. We estimate that ChatGPT consumed approximately 0.2 terawatt-hour of energy only for the inference in 2023. This is equivalent to the annual electricity consumption of 40,000 average households in New York City. Based on very limited data provided by OpenAI, it is estimated that ChatGPT emits approximately 8,000 metric ton carbon dioxide per year. This is equivalent to the annual emission of approximately 1,800 cars. It is important to mention that the companies developing large language models are sharing very limited data on models' energy and carbon footprint. But what about the future energy footprint of AI models? How much increase do we expect? There have been few forecasts on future energy consumption of AI models published recently. However, before diving into those, we first want to go back in time and see the energy impact of technological booms similar to AI. As we previously mentioned, many people find the AI boom quite similar to the revolution of internet. So let's see how the internet and its energy impact has grown in the last few decades. The birth of internet radically changed the way we do things, from business and education to entertainment and socializing. It was a true revolution and brought immense prosperity to the global economy.
Back now at 56 past, I wasn't prepared to translate that as I was doing that little tease.
Oh, that's
that little
right.
mark with the A and then the ring around it.
At?
See, that's what I said. Katie said she thought it was about.
Yeah. Oh.
But I'd never heard it.
Around
I'd never
or
heard it
about.
said. I'd always
That's
seen the
right.
mark, but never heard
Yeah.
it said. And then it sounded stupid when I said it. Violence at NBC.
What would be around
big
or
fight
about?
up in the lunchroom the other
See,
week.
there it is. Violence at NBC. GE com. I mean,
Well, Allison should know.
what
do you
is
say to that,
internet
Allison?
anyway?
Internet is that
In
massive.
between 2000 and 2020, the global internet traffic has grown by a factor of 3,000. Energy was the major factor making this digital transformation possible. Let's break down the energy consumption of internet to better understand this. The internet consumes energy due to the infrastructure that support its operations and devices we use to access that. Data centers are the backbone of internet. These are facilities filled with servers, which are powerful computers. Servers store, process, and distribute vast amount of data, and they run 24/7. It is needless to say that servers require significant amount of electricity to operate. Additionally, data centers need cooling systems to prevent overheating, which also consumes energy. On the other side, there are billions of end-user devices, such as smartphones, laptops, and other devices which people use to access the internet, and they all consume energy. And last but not least, there is a complex connected network infrastructure consisting of cables, routers, switches, and so on to transmit the data across the world. Network is like a bridge between the end users and data centers. So, in a nutshell, this is how internet consumes energy. A lot of energy. In fact, in 2020, ICT sector used about 4% of the global electricity and represented 1.4% of the global GHG emission. You can see that as the internet traffic has grown, the amount of compute performed by the data centers has increased, and consequently the energy use. Data centers have always had a major problem, and that was keeping the energy use under control. This problem has mostly been well managed so far. Despite 1,590% growth in global internet traffic and 840% growth in compute instances of data centers from 2010 to 2020, the energy use of data centers has only increased by less than 10% in the same period. In other words, data centers have become super efficient. So, efficiency measures have kept the energy use problem of data centers under control so far. But this problem gets way bigger with the AI explosion. The energy use of data centers, which only increased by 10% from 2010 to 2020, is expected to double until 2026. This is simply due to the energy-intensive nature of AI servers. Currently, there are two well-known AI servers in the market, both produced by a company called NVIDIA. These are DGX A100 and DGX H100. They have power consumption of 6.5 kilowatt and 10.2 kilowatt. To put this in perspective, think of an average server used by a traditional data center. It has a power consumption of 0.3 to 1 kilowatt. So, in a nutshell, these AI chips are simply energy-sucking beasts. NVIDIA was expecting to deliver 100,000 of them already in 2023. By 2027, NVIDIA could be shipping 1.5 million of these chips. This means the AI industry could consume around 100 terawatt-hour of electricity already in 2027. This is enough electricity to power the entire Netherlands for the whole year. Despite all this, there are also some factors that can limit the energy use of AI industry in the coming years. One of the major limiting factors is AI hardware supply bottleneck. Currently, 95% of the AI chips are being produced by NVIDIA. The surge in demand for AI computing has led to GPU shortages as the demand exceeds the current supply capacity. The second limiting factor for the energy use growth of AI industry is the cost. Traditional high-performance CPU that is used in traditional data center costs around $10,000. However, NVIDIA H100 is sold at around $270,000. This huge cost increase is slowing the pace of AI adoption for many companies. For example, Google. Do you know why Google has not yet fully integrated AI into their search engine? Because it costs money, a lot of money. In fact, if Google were to integrate AI into every search, that would require more than 500,000 AI servers and would cost Google up to $100 billion. And this would have easily bring operational margin of Google down to zero. Last but not least, let's not forget the possible technological improvements and efficiency gains in AI chips and in data centers, which can limit the expected energy use growth of AI industry. So, despite all these limiting factors, we strongly believe that the AI industry will have an energy footprint that is as large as the medium-sized countries such as Pakistan or Argentina in just a few years. The demand and investment in AI industry is so intense. It is so intense that the market cap of NVIDIA has grown by a factor of 21 in the last 5 years. And it has become the third largest company in US after Microsoft and Apple. Substantial investment will solve the supply bottleneck problem and will bring the cost down. This will radically increase the AI adoption by companies and consequently increase the energy use of AI industry. Our only hope is that NVIDIA chips will be getting more and more energy efficient. It is important to understand that every technological revolution comes with a substitution effect. With the internet revolution, emailing superseded the act of sending a letter, streaming a movie superseded renting a DVD, and video calls superseded the in-person meetings, and so on. With each cycle of substitution, we get more efficient with the way how we use our resources. To write down a single page of a letter with a pen, my grandfather would have been emitting nearly 1,400 grams of CO2. My father does that in his laptop and only emits 27 grams of CO2. And I do it with AI and only emit 1 gram of CO2. Because we're using less resource per unit of work with every cycle of substitution, we tend to increase the volume of useful work in total with every technological revolution. For example, because writing a letter is now way easier and less resource intensive, I am able and incentivized to write way more letters than my grandfather did. And this does not only apply to me, but the entire humanity. This does not apply only to writing a letter, but applies to all kinds of activities that are impacted by the new technology. With every technological revolution, humanity gets more efficient and more empowered. It is true that the energy use of AI industry will grow and has associated problems which we have to deal with. But it is also true humanity will get way more empowered.
Internet is that
Massive computer
right,
network.
the one that's becoming really big now.
What do you mean that's big? How does one? What do you write to it like mail?
No, a lot of people use it and communicate. I guess they can communicate with NBC writers and producers. Allison, can you explain what internet is?
No, she can't say anything in 10 seconds or less.
Oh, Allison will be in the studio shortly.
What is
What
it?
does it mean?
It's a giant computer network made up of started from.
Oh, I thought you were going to tell us what this was.
It's like
You've
a
been looking in the
computer
dictionary.
billboard.
It's not. It's